rectangular to spherical conversions for coordinates. Let's take number 31. So we're given here a point that's in the rectangular coordinate system. So x is equal to -2, y is equal to 2 times the square root of 3, and z is equal to 4. So from here we find rho. Rho is the square root of x squared plus y squared plus z squared. So this is the square root of -2 to be squared, which is 4, plus y to be squared, which is 4 times 3, we get 12, plus 4 to be squared, we get 16. So that gives us the square root of 32, and that's 4 times the square root of 2. So we're given a point in the rectangular coordinate system, which is x, y, and z, and you want to convert that to a point in spherical coordinates, which is rho, theta, and phi. So secondly, let's find theta. So to find theta, we use tan theta, which is equal to y over x. Well, y is equal to 2 times the square root of 3, and x is equal to -2. We can simplify that. This is the square root of 3 over -1. I want to leave it like that so you can see where the negative and the positive would come from. If you recall talking about the reference angle and looking at the 30, 60, and 90 correspondence, and if this is a 30, 60, 90 triangle, this side is set to be 1, this is 2, and this side here is the square root of 3. So here we have 30 degrees, or excuse me, this is the 60 degrees, so this is pi over 3, and up here is 30 degrees, or pi over 6. And so we try to map out from here how can we form the tangent theta of the square root of 3 over 1. And so it looks like we're looking at pi over 3 as our reference angle. Because pi over 3, the tangent of that would give us the square root of 3 over 1. We have a -1 there, so the reference angle is not the true angle. If we look at the 4-quadrant system for sines, x is negative and y is positive. X is negative, y is positive. That puts us in the 2nd quadrant. So the angle theta is equal to pi minus the reference angle of pi over 3. So that gives us 2 pi over 3 for theta. Now secondly, we want to find phi. We use cosine phi to find the angle phi. So cosine of phi is z over rho, because we have z and we have rho. Z is 4 and rho is 4 times the square root of 2. Well, that gives us 1 over the square root of 2. So this implies that phi is equal to cosine inverse of 1 over the square root of 2, and that is smack dab we know the angle is pi over 4. So the point in spherical coordinates, rho is first. This is 4 times square root of 2. Theta is next, 2 pi over 3. And then phi is last, pi over 4. Thank you.